Hello and welcome to the next session of the R workshop. I guess this is session 6, I think, because we had 4 of the intro prepared content, and this is the second one walking through an example data set. As a quick refresher, I have some real data from a study that I did with my colleague Rosanna Summers, and I was walking through detailed step-by-step approach to processing and then analyzing the data. And we're partway through the processing file. This is some of the things that I do in this file are not necessarily things that I would recommend in general, just one way of doing it that works in this case. But one general recommendation I do have is that it's a good idea to have data processing code that is in a single file that can be run at once in order to turn your raw data into your data ready to analyze anytime you want. And I like to keep the most of the statistical analysis separate from that. It doesn't necessarily have to be that way, but at least having something that you could conceivably share with someone for how to transform the raw data into the data you actually used can be helpful. What I've done here is start R in the directory that has my example data and the code files that I already shared with you. And last time we got through this point in the code file where you can see the cursor is. And this is the processing file. They can all be run at once. So I'm going to just select through the beginning and rerun it. We're going to get probably a couple of warnings about my version of R being old. Oh no. And some tables and stuff that I had printed to the console before as examples for you. But nothing in here is an error message, so that's good. The only warning is this thing about masking an object from another package, which is fairly common. I anticipated that it would comment on my R version being old, which it is. Do update your software. Sorry that sorry that I'm still working with Kite Eating Tree. Yeah, so where are we? Here we are. We had just made a bunch of copies of variables that had been altered to make them more usable. And these are temporarily in the global environment. Again, this is not the way that you have to do it. I'm just doing it this way in this example because I think it makes it very clear what's going on each step of the way. And at the end, I'm going to take all these variables from the global environment and put them in a new data frame for analysis. So some of those include our condition variable legal, or things like I would vote to this item that was I would vote to ban discrimination on the basis of history of depression or mental illness. As a quick reminder, in this study, we manipulated the outcome of a hypothetical court case in which a job applicant named Amy, who had a history of depression, had applied for a job and was denied it on the basis of her mental illness history and sued for discrimination. And in one condition, she won the lawsuit. In the other condition, she lost the lawsuit. And the judge said that such discrimination was permissible under the law. Okay, so continuing from where we were before, the next items that I want to do something to are these feeling thermometer evaluations of Amy. And they were items about positive, warm, and favorable feelings toward Amy. And all I'm doing here is running the recode command from the car package with the variable in the raw data set specified, which is, as another reminder, currently attached, so I can refer to names of variables that are in that data frame without referring to the data frame directly. And I'm changing negative 99s to missing values because I had Qualtrics specify participants who saw but did not answer a particular question using negative 99. I'm pretty sure that I've already done this several times with other, yep, I did it a bunch of times up here in the syntax file, so this is nothing new. And there will be a lot of, the rest of this file, this processing file, for a little while is going to be repetition of things that I did before, so hopefully I'll be able to walk through it pretty quickly. So here I'm just creating copies of these variables, Amy, positive, warm, and favorable. And I'm going to calculate this composite based on those 3 items, which is how I intended to do it in the first place. These 3 items about Amy being positive, warm, and favorable all happen to be highly correlated. I'm not going to show you that here, but you can take my word for it. And so I'm creating this this single index that's the average of the 3 of those. The row means function is one I've already showed you as well. Then we have similar kinds of ratings of people with depression and people with mental illnesses generally. These work the same way as the evaluations of Amy, so I can run all of those. And I'm going to use row means again to create some composite scores here. This one is the evaluation of people with depression in general, people with mental illnesses in general, and then this one is a combination of those 2, which I calculated for my own convenience later because it turned out that the all 6 of these items about people with depression and people with mental illnesses were so highly correlated that it made sense to not really analyze them separately. Okay, these items are very similar. These are not feeling thermometer sliding scales, but Likert items, but they still have -99s in them. So all I'm doing is replacing those with missing values and creating some composite scores here. These are 3 different composite scores. Well, they're really 2 different ones and then a bigger one representing the all 6 of those items. That just represent a social distance measure for people with depression, people with mental illnesses. The next thing I decided to do, in case it's useful to you, is combine items into a scale score in a slightly different way. I'm going to sort of notice that the feeling thermometer ratings based on warmth, favorability, and positive feelings, and these social distance items, being willing to be friends with a person, avoiding people like that, and not wanting to have someone with that designation marry into my family, were all highly correlated. And a simplified way of looking at that, although this is not necessarily always a good idea to do, is just to look at the correlations between the a priori clusters of items that I was already going to combine together. So here I have evaluation of people with depression and people with mental illnesses and the social distance measures for those 2 groups. And I noticed that these 6 correlations among these 4 different scale scores, each of which was computed from 3 individual items, these are all highly correlated. And so for convenience later, one thing that I can do is combine them into a single overall scale. I'm still C-binding all of these items. Now there are 12 items, but before calculating row means, I'm using this scale function, which I don't think I showed you yet, but it comes from the psych package, I'm pretty sure. I'm just going to double check that. This is not the only way to double check it, but this is one way. No, it's in the base package. My bad. Yeah, scale will just z-score everything in this matrix after I create the matrix by c-binding things. Well, really, it's a data frame, not a matrix in this case. Z-score all of the items, and then I calculate composite by averaging them all together, all of the z-scores. And the reason that I did that in this case is that they are all on different scales. Well, they're not all on different scales, but half of them are on a 0 to 100 scale, and half of them are on a 1 to 7 scale. So I called this variable standardized evaluation. It's not really a standardized version of an evaluation variable. Instead, it's an evaluation variable based on standardized versions of 12 items, but that's a good enough shorthand. Here's an alternative approach. I created this min-max function earlier. It's in the extra functions file that I provided you all, and that this processing file called. So all of the functions from the extra functions file are available right now. One of them is called min-max, and it's a very simple function, and I've already showed it to you before in a different example. So if you remember, it rescales a variable so that it has a specified minimum and maximum. Here, what I've done is I've called that function repeatedly for each of these variables to rescale them to the range from 0 to 1, but I've specified that the theoretical minimum and maximum should be treated as 0 and 100 for each of these sliding scale variables, and as 1 and 7 for each of these Likert type variables. So instead of z-scoring them, I'm bringing them all down to a range from 0 to 1, where if a participant had responded at floor, they would get a 0, and if they had responded at ceiling, they would get a 1, regardless of how many points there were in between floor and ceiling on each of these measures. As a quick comment up here, when I did this version, I used 8 minus, this TEPR avoid variable and several of these others in order to reverse code them. So wanting to avoid people is an indication of not liking them rather than an indication of liking them. And these are 7-point scales ranging from 1 to 7. So 8 minus that variable will result in a reverse scored version of it. And I can do that directly in the call to cbind. I'm doing the same thing here except with 1 minus because I've already called my min-max function in order to change the range to 0 to 1. So if I run this evaluation variable based on z-scores and evaluation based on min-max, I'm just going to illustrate to you how similar they are. This is the horizontal axis represents the evaluation based on standard z-scores of the 12 component variables, and the vertical axis represents the evaluation composite based on min-max normalization of those same 12 variables, and they're nearly identical. So I'm just going to pick one of them, but I showed you how to calculate both. We're going to use the z-score one because that's what my comment here says that I'm going to use in the analysis file. The next step I have here is taking all of the items from the authoritarianism scale, the right-wing authoritarianism scale, and coding -99s as missing, and then calculating a composite for right-wing authoritarianism. This is one line of code down here. It's a big block, but it's just one long line that is row means of cbind of the entire list of variables that are included on that scale, several of which are reverse scored with 8 minus the variable. So no RWA exists. I can, for example, view a histogram of it. It's right skewed, as it often is. This next section is exactly the same, but for a need for cognition. So I have coding all of the -99s as missing and then calculating a composite. And the next section is exactly the same except for this trust quartz measure that comes from some of the work of Tom Tyler. And then we have some questions about other laws that people might have opinions about, and I'm pretty sure I'm not going to go into those in the analysis file, but I just coded the -99s as missing here.